Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to our deep dive tutorial on Apache Sqoop. In this video, we'll explore what Sqoop is, why it's essential for big data engineers, and how you can leverage it to move data efficiently between relational databases and Hadoop. Whether you're preparing for a certification or working on real-world projects, this tutorial will give you the insights you need. Apache Sqoop is an open-source tool that enables efficient bulk data transfer between structured data stores like MySQL, PostgreSQL, and Oracle, and Hadoop. It leverages MapReduce to parallelize data movement, ensuring scalability and fault tolerance. Sqoop supports both full and incremental imports, making it ideal for ETL workflows. Sqoop excels in scenarios where large volumes of structured data must be moved quickly and reliably. Its integration with MapReduce ensures high throughput and resilience. Additionally, Sqoop supports numerous database connectors out of the box, simplifying connectivity to popular systems like MySQL, Oracle, and SQL Server. While Flume handles streaming data and Kafka Connect integrates with event streaming platforms, Sqoop is purpose-built for batch transfers between relational databases and Hadoop. Compared to Spark, Sqoop is more specialized but less flexible. Understanding these distinctions helps in choosing the right tool for your use case. Sqoop operates using a client-server architecture. The client submits jobs to the Hadoop cluster, which then executes them as MapReduce tasks. Connectors act as bridges to various RDBMS, handling metadata extraction and data mapping. During import, Sqoop first retrieves schema information from the source database. It then generates MapReduce jobs with multiple mappers to read data in parallel. The output is stored in HDFS in formats like Avro or Parquet, optimized for downstream processing. Exporting data involves reading from HDFS and using reducers to insert or update records in the target RDBMS. Sqoop ensures data consistency and handles schema mismatches through configurable options, making exports reliable and efficient. Sqoop provides a rich set of CLI commands for managing data transfers. The import and export commands are core, while list tables helps discover available tables. Eval allows you to test SQL queries directly against the database. Sqoop ships with a generic JDBC connector that works with most databases. For optimized performance, vendors provide specialized connectors for Oracle, SQL Server, and others. You can also build custom connectors for unique data sources. Sqoop import offers granular control through options like table for specifying the source table, where for filtering rows, and split by to enable parallel reads. The incremental option supports efficient delta loading based on timestamps or ID. Export commands allow specifying target tables, handling upserts with update key, and defining field delimiters. These options ensure data integrity and compatibility with various database schemas. Sqoop jobs can be saved and reused using the job command. Integration with Apache Oozie allows scheduling, while monitoring through Hadoop UI provides visibility into job execution and performance. Performance tuning in Sqoop involves adjusting mapper counts, enabling direct mode for native database connectors, and choosing optimal split by columns to balance workload across mappers. Sqoop integrates with Hadoop security frameworks, supporting Kerberos authentication and SSL encryption. These features ensure that data transfers are secure and compliant with enterprise standards. Sqoop is widely used in ETL pipelines to ingest transactional data for analytics. It also powers data warehousing workflows by feeding Hive tables and supports large-scale database migrations to Hadoop environments. Despite its strengths, Sqoop has limitations. It doesn't handle complex data types like nested structures well. It's also inefficient for small datasets due to MapReduce overhead. The community has largely moved to Spark for more flexible and performant data transfers. Sqoop 2 was a major rewrite aimed at improving usability with a REST API, enhanced security, and better monitoring. However, it never gained widespread adoption due to lack of backward compatibility and limited feature parity. As big data evolves, alternatives like Apache Spark offer more flexibility and performance. Kafka Connect handles streaming data, while custom ETL pipelines provide full control. Choosing the right tool depends on your specific requirements. To get the most out of Sqoop, use incremental imports to avoid full data reloads. Monitor job performance regularly and ensure sensitive data is encrypted and access controlled. Installing Sqoop is straightforward. Download the latest release from the Apache website, set environment variables like Java Home and Hadoop Home, and verify the installation with Sqoop version. Sqoop configuration involves editing Sqoop site.xml for general settings, log4j.properties for logging, and placing JDBC drivers in the lib directory for database connectivity. When troubleshooting Sqoop, always check the logs for detailed error messages. Ensure JDBC connectivity is working and use Sqoop eval to test queries directly against the database. Sqoop integrates seamlessly with Hive, allowing you to import data directly into Hive tables using the Hive import option. It can also auto-create Hive tables based on the source schema. HCatalog acts as a schema registry, allowing Sqoop to automatically infer schema mappings. Using HCatalog table eliminates the need for manual schema definitions, reducing errors and saving time. Oozie enables scheduling and orchestration of Sqoop jobs. Define workflows in XML, set triggers, and monitor execution through the Oozie web UI for automated data pipelines. Monitoring Sqoop performance involves tracking mapper execution times, data transfer rates, and error rates. These metrics help identify bottlenecks and optimize job configurations. Securing Sqoop involves encrypting data in transit with SSL, using Kerberos for authentication, and restricting access to Sqoop jobs through role-based controls. Sqoop integrates with core Hadoop components like HDFS, MapReduce, and Hive. While part of the legacy stack, it remains useful for specific use cases, though modern stacks favor Spark for flexibility. Sqoop benefits from an active Apache community, extensive documentation, and forums for troubleshooting. Commercial support is also available from vendors like Cloudera and Hortonworks. Certifications from Cloudera and Hortonworks validate Sqoop expertise. Online courses, tutorials, and hands-on practice with real data sets are great ways to master Sqoop. While Sqoop is deprecated, it remains in maintenance mode. The community encourages migration to Spark, with guides available to ease the transition. In retail analytics, Sqoop imports sales data from MySQL into Hadoop. Tools like Hive and Pig process the data, and results are exported to PostgreSQL for reporting dashboards. Financial institutions use Sqoop to migrate legacy Oracle data to Hadoop. Data integrity is validated, and incremental updates are scheduled to keep systems synchronized. Telecom companies use Sqoop to import call detail records from SQL Server. Spark analyzes the data, and results are exported to a data warehouse for business intelligence. This chart compares Sqoop's performance against Spark, Kafka Connect, and Flume across throughput, latency, and scalability metrics. It highlights Sqoop's strengths in batch processing and limitations in streaming scenarios. To master Sqoop, start with Hadoop and MapReduce fundamentals. Learn SQL and JDBC for database connectivity. Practice Sqoop commands extensively and explore modern alternatives like Spark for future-proofing your skills. Thanks for watching this comprehensive tutorial on Apache Sqoop. If you found it helpful, don't forget to like, subscribe, and comment with your questions. Check out our other big data tutorials and stay tuned for more exciting content. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.